So a quadratic identity. We looked at trig identities, you remember, earlier in the year. Now, an identity is when it's exactly equal. So another way of saying it, I suppose, is congruent. Congruent triangles are sort of like identities as well. So a quadratic identity is when two quadratics are equal, but they're equal for more than two values of x. So it's not an equation to solve. Right? They will always be equal. It doesn't matter what value of x we put in. Therefore, as I say, that means these parabolas, if we were looking at the picture, the two parabolas would be congruent. They would fit on top of each other. So if that's true, they've got to have the same equation. So the coefficient of x squared would equal the coefficient of x squared, the coefficient of x would equal the coefficient of x. The constant should equal the constant. So what it means is questions like this, and you'll notice instead of an equals symbol there, I have a congruent symbol. So that's one way they might answer the question. So what they're basically saying is these will be equal for more than two values. They're always equal. They are identical. The other way you might see the question is they might just have equals, but then they'll mention for more than two values of x. And so they're talking about, these two parabolas are congruent. So if this is true, I know the coefficients are equal. So I could equate the coefficients. Expand the whole thing out. Group the x squareds together, group the x's together, group the constant together. And now I can equate the coefficients. So a must obviously be 2 in this case. 4a plus b is negative 7. Which gives me negative 15 for b, because we know what a is. 4a plus 2b plus c is equal to negative 4. But then substituting in what we know, and we get c is 18. So alright, I have my three values. Instead of equating the coefficient of x squared, I could do it via clever substitution. And then I don't have to expand the whole thing out. If I was to make x equal to, say, negative 2, then on the right-hand side, the term with a would disappear, the term with b would disappear. I could find c straight away. I get 18. I could use x equals 0, because that's a really easy number to substitute in. X equals 0 would give me 2a plus b is negative 11. I'll pick another number, 1, again, I'm just picking easy numbers. And that gives me 3a plus b is negative 9. Simultaneous equations, I can then get a and b. There we go, we get the same answers. Or of course the other thing I could do is I could combine the two ideas, and that would make it a lot quicker. So I could have chose negative 2 to find c. But to find x squared, I don't have to expand the whole thing out, because there's only one term here that will end up with x squared. So I know when I expand the whole thing out, I would have got ax squared. So the coefficient of x squared must equal the coefficient of x squared. I get a equals 2 straight away. I now know c, I now know a. I could now find b via substituting in a very easy number, and I probably would pick 0. So you can combine the two ideas to save time as well. So just a little bit there. Oh, how many questions is that? That's way too generous, isn't it?
Probably like 10 questions in
You reckon? Okay, see how we go.